Greetings! Welcome to the 14th Baz tutorial. My goodness, it's been so many tutorials. Alright, I'm going to do a couple of things today, talk about how to change the pitch of sample playback, and I'm also going to talk about changing pitch using delay, I guess you would call that pitch shifting. Alright, so we're going to play back samples. Good idea. We're going to use a groove tilde, which means we need a buffer tilde first. So let's make a buffer tilde, a new object with my N key, buffer tilde. I'm going to call this buffer, I'm going to call it vibe, because I'm going to load in a sample called vibes-a1.aif. You can get a bit of a close-up on that one, in case you want to make sure you've got the name of that sample right. This vibes a1.aif is again one of those things that lives in the examples folder, so Max knows how to find it. I'm going to use myself a groove here, N for a new object, groove, with the same name, vibe, as an argument, so it automatically looks at this buffer called vibe. And we need a couple things to play back the buffer. One is a new object called sig, which is the speed of playback. That's what we're eventually going to change, but at the moment we'll set it to 1, which should mean it plays back the same the pitch that the sample was recorded at. And I need a message start loop, so M for new message and start loop is the message that makes groove tilde do its grooving. So that's what it plays back. And then we'll need an easy DAC to go with this thing, just so we can hear this, how amazing this sounds. Hook up the left outlet of that groove to the easy DAC, turn it on, and we should hear it already. Dong. Yeah, if you're not hearing that, especially when you hit the start loop, where you obviously don't have that sample loaded, you can double click groove to see it, and if you haven't got it playing back, probably the most likely thing is you need to check the spelling on the vibes-a1.aif. Alright, what we're going to do, we're going to talk about first, eventually we're going to talk about how to change this value to relate to pitch. But first let's talk about how to make this sample sound halfway decent. For a $500 piece of software, Max comes with the worst samples in the world. We could at least get rid of that stupid click off the end of that sample. And for that I might use this loop sync output right here, which is a signal that goes from 0 at the start of the loop to 1 at the end of the loop. And I suppose we just want to invert that so it, as an amplitude, it starts at 1 and goes to 0 at the end. And to do that, I'll make a new object with a exclamation point, minus, and tilde, which is one of the funniest looking operations you'll ever see. Exclamation point minus tilde, which means it's a reverse operand subtraction, meaning to say whatever signal comes in here, it'll be 1 minus whatever the signal will come in here. So essentially just inverting this range 0 to 1 so it goes 1 to 0. And I'm going to multiply this outlet of groove by that value coming out of that reverse multiply. So a new object here, multiply tilde, asterisk is what we use for multiply in case you hadn't already got that. And here we go, multiply the output of the groove by the outlet of the output of this reverse operand multiply, and it sounds like this now. Yay, so it fades towards the end instead of being rudely cut off. That's almost a $500 sample right there. Okay, let's look at how we're going to change this value here. Let's just put a float here for the moment, which is F on my keyboard, so we can, well, let's have that trigger the start loop as well so we can check it out. So if we put a 1 in here, it plays back at pitch like we already did. 2 plays an octave up. My guess is that 4 plays 2 octaves up from the original. And 0.5 should play an octave lower. Even though that sample is so noisy, it's kind of impossible to tell that that's an octave lower. Alright. So what we need is something, let's say, that makes that 1. We're going to relate it to MIDI somehow. We're going to use MIDI for this. So let's make a new object. M to F is what we're going to use. And for just to check it out, let's hook up a couple of, let's put a float output from this M to F. Make it a little bit wider so we can see it. And I'm going to use an integer. That was F to get that in. F for the float, I for the integer box. Let's get one of those. So we'll see that if we put a 60, let's say, into the M to F, we get this frequency 261.62558. And if we get a 72, which would be an octave above that 60, we get double that frequency. So we can use something like this frequency of a MIDI note 60 as a reference value. Let's say we'll make that value 261 point blah blah blah. We'll make that equal 1, and then a 72, which was twice that number, we'll make that equal 2. Quite obviously, maybe already you can see this, is that a new object, and if we divide by whatever comes out of that M to F, if we divide that value by our reference frequency 261.62558, like so, then according to my theory, according to my calculations, this should now be using this. We should be able to now use this as a kind of a MIDI pitch. So 60 is that pitch, 72 is an octave higher, 84 is 2 octaves higher, and you have all these half steps or semitones, depending on what part of the world you come from. You have all those numbers in between. Yes, indeed. All right, so let's, now what do I want to do? Oh, I just want to do something a little spicy to have the playback of this thing happen. And I'm going to do some kind of like cycle of fifths, or actually we'll just talk about how to generate a scale using fifths. Let's start with a metro. You know how much I love metros. A new object with metro. We could put an argument in there, 500. Let's say we'll trigger it every 500 milliseconds. So it'll have a bang come out every 500 milliseconds. We'll usually have a toggle, so T on the keyboard for a toggle to turn the metronome on and off. And then we have a random. I'm going to make a random, new random. I'm going to have 5 because I'm going to make a pentatonic scale. So there's going to be 5 different notes. And those 5 different values, 0 to 4, I'm going to multiply, so a new object, multiply by 7. So that's going to give me a cycle of fifths. In case you didn't already sort of see that, a fifth, let's say C to G or G to D, is a space of 7 half steps or 7 semitones. I'm going to keep all of these numbers within 1 octave, and to do that I'm going to use a modulus operation, which is % sign on your keyboard. Modulus 12 will keep all of those numbers within an octave. Modulus is like the operation you did in grade school where the teacher would say, I have 5 apples and I have 2 students, Jim and Jack, and I have to divide these apples up, and each of those students obviously will get 2 because 5 divided by 2 is 2, and the 1 remainder, that's what would relate to the modulus. So modulus 12 is 0, 13 modulus 12 is 1. So everything over between a 0 and 11, anything else will just wrap around that modulus. Okay, and I'll just choose a base value for this, so plus, I'm going to start at an octave above normal pitch or the sample recorded pitch. So that's now going to be some coming out of here, some value between 72 and whatever, 83. And it'll sound something really groovy like this. Almost Mary Had a Little Lamb, but I just stopped it a little too late.